Think for these what do we call it, sci-fi or lumen related stuff, do know I'm always available. So yeah, so yeah, let's go. We are live and let's start off, right? So you guys can see the screen. Also my webcam and my audio is clearly audible, right? If anyone could kindly confirm that, I would be really grateful. Ari and Awaz. Perfect. That's great to know. All right, guys. So yesterday we had a pretty great discussion on introducing the topic, chapter number 4, which was all about softwares. And we studied that there are two types of software, right? The system software and then the application software. And we ended the class basically on this diagram where we were exploring the multiple examples. Like it's not like it's limited to only these, but these are like the common examples that come under when we discuss the application software topic. And right now, we basically yesterday covered up 6 of the 8 examples. So we're going to start off with the remaining 2, and then we will be shifting towards discussing the system softwares and their possible examples and how they are used. So you're going to note that examiner up here would be keeping a greater emphasis on the system software. So like while doing system software, we won't be summarizing it this way. We need to expand on each of the software a bit separately, which is again a hint for everybody that while preparing, these are things that you should be aware of because they can be asked. But usually examiner emphasizes more upon the system software. I don't know for what reason, even though both of them are similar though, but still, right? So you're going to be acting on the manner where we need to ensure that we are the most safe among all the candidates, right? So we won't be taking any sort of risky move. So coming back to our discussion on application softwares, now you need to understand that we last night did the last one as a video editing software, right? Which basically allows you to manipulate videos. Today, we're going to be looking into a graphics manipulation software. So what's a graphics manipulation software and how is it basically different from photo editing software? At first glance, wa alaikum assalam, Ramin, how are you doing? In the first glance, you might be thinking that while talking about graphics manipulation, it might be somewhat similar to the photo editing part, right? But to be honest, they are a bit different. So at your level, at IGCSE level or O levels stage, you are not required to know these graphics related stuff. You would be introduced to this concept when you study computer science in your AS level, inshallah. But do know that basically you can create sometimes a model which can basically be expanded, or like if I can say that I want to create a basic outline of something, so we can basically create such graphical images. These graphical images do not include the pixels which we studied in chapter number 1, that basically pixels are those different representation of color. Like when we combine all these different colors or the different pixels, we have an image being formed. So the photo editing software basically deals with the images, and images are made up of pixels. Whereas when we talk about graphics manipulation software, it's basically those softwares which deal with bitmap and vector images. So these are those type of images which do not include pixels, but they basically include other sort of elements. And those elements are basically used to create diagrams which can be expanded and can have multiple sort of graphical features. So maybe I want to create a model of something, or if I want to create a prototype of something. So we basically make use of these graphics manipulation software, right? So those are thingies, what do we call it? Those are basically those type of things which for which we need a graphic manipulation software. Now, more details are not relevant, but you should be aware that we have a specific type of application known as graphic manipulation software, which basically allows these bitmap images and vector images to be changed. So what are bitmap images? These are those specific type of images. Now we have two types of images. One is bitmap and the other is vector. Bitmap are those which have the pixels in it, but these pixels include image brightness and color related information, somewhat similar to the photo editing software. But then we also have vector images. And what are like bitmap graphics? These are basically those specific sort of editors that can change the pixel to produce a different image. Now this is also for this same bitmap one. Vector graphics are a bit different things. Now vector graphics is the one which I just told you previously. Rather than having pixels, they do not basically work upon pixel. Rather they have lines, they have curves, they have text, which basically allows them to create a so did you do system software yesterday? No, we did not do system software. This is basically application software ki ek do example, and then we're going to start off with system today. So yeah, don't worry. So you can cover up system today and can rewatch the recording preview Kalki aaj, basically yeah Kalki, and you're gonna understand the application software in the right way. So now coming back to where we were. So now we have the graphic manipulation software. Is that specific software which then allows you to edit these vector graphics too. And when we edit these vector graphics, because they do not include pixels, they are basically made up of different sort of lines. So like I want to create a model like this, might be a square, I can add a rectangle, sorry, a triangle up here, I can add a semicircle, and this basically might be some shape, or maybe a robot I want to create, so one two other squares beneath, and maybe I want to add something up here, so a box like this, and this might be some robot I might have created for some purpose. So to create the model, I might be using a vector model, right, a vector graphics image. So to alter those vector graphics image, we basically need a graphics manipulation software, which is again because it has a specific use and something between graphic manipulation and photo. Okay, so you see, basically you have two types of images. One is the one which makes use of pixels. See, one makes use of pixels. Now, this difference is not something which would be directly tested in your exam, that what's the difference between graphic manipulation and photo editing software. And even though the difference between bitmap images and the vector graphics is something which would be taught to you in AS level, but just for your own understanding, what pixels were, that basically if I want to create an image, if let's say I've had this image which had this mountain was basically created in a way where we had multiple smaller boxes. So like this whole image was divided into small chunks of boxes like this. And then basically each of the box, so like something like this. And we called each of the box a pixel. Remember chapter number 1. And we said that each of these box can basically have a different color. So when this might have like white, this could be having some other color, this might have some other shade, and just like that, this could be the mountains color, and blah blah blah. And eventually when you add and join all these pixels which are listed separately and you make them a single image, you're going to note we have an image created with us. Now, if I want to edit this specific image, where I might want to add, let's say, some element onto it, I want to add some sort of other colors, I want to edit the brightness or something. For that, I will be making use of a photo editing software. Say for a photo editing software. Now, the graphic manipulation software is the one which can also do this part. So your graphic manipulation can also deal with this. They can change the brightness or stuff, but they're basically built for another type of images, which we call as the vector images. Now, vector images do not have these pixels. It's not like you need to basically color this way and this one a bit other, and then this a bit other, and then this something like else, and then this is going to be like looking like a shape. It's not going to operate in this way. In vector, you are basically given the permission to create lines. So if I want to create a model of a mountain, I can directly create two lines. And these are not like based upon the pixels. They are basically something which I can directly create a line, and then I can basically extend these lines. So for instance, it's up to me. So I might create a line like this, and maybe I want to extend it. So I'm not sure if we can. Oh yeah, so you see now this is a vector image. Why? I can basically resize it wherever I want. So like you see, I can change it like this, I can change it like this. It was maybe like this much, but I want to extend it to this much. Now I did it this is like a vector. Now I can't do this one, right? I cannot change this one. Why? Because these lines which I made up here, these are more or less pixel based, right? But this one which I just created, which I can change its size and stuff like that, that is known as a vector image. So a vector image is that type of image in which you basically create a model, but using these, what do we call it, lines, and then you can add text to it. Hi. So this specific sort of image does not include any sort of, but won't the concept be same? So no, the concept is same, but there's a bit of a difference to it. Up here, basically the image which you are looking up here, it's basically formed by the different color combination. Each small box was representing a different color, and then all these different colors were combined together, and eventually on your screen you were able to see a proper image. Up here you are not looking at colors. It's not like that this point has a specific color, this point has a specific color, this point has a specific color. These are lines. One other difference which you need to understand is that this specific image, in this, if I want to extend these mountains, or maybe I want to make this a bit smaller, I cannot change it, because this was something created by a set of colors. Right here in vector graphics, because this has been made up of lines, I can basically alter it the way I want. So if I, let's say, want to change this specific line, I want to make it something like this, I can do it. Why? Because this is a vector. But it's not possible that you have an image in front of you like the one which you have. Exactly, that's pretty much so pixels are like a color. Not ideally, it's more or less you can say that. अब मैं कैसे explain करूँ? For instance, it's basically something like, see, I can say that I have like, okay, I'm creating this one model for you. There is this yellow light. Can you make any sense out of it right now? No, right? Then I have something like a blue up here. Can you make any sense out of it right now? No, right? Okay, unable to make any sense. Then let's say I have something like this around this. Now, can you somewhat make sense out of it? Maybe somewhat you can make sense out of it. You would be able to see that this might be some sort of the sea, right? And then you have the sun, and this is the sky. Now you get this image at the end, right? But what computer understands it that while creating this image, this was basically each of this blue part was a small box, which we are calling as as a pixel. So each of the pixel had a different color. Like these boxes were extending the whole place, and then everywhere we had a specific box. Now, if I want to view one of them individually, it would not make any sense out of it. But if I create and have these multiple colors all joined together, then you can see that I have this one diagram formed up. But right now, I cannot basically change the diameter of the sun. Like this part has the yellow color. So I cannot basically alter the color. It's like I tell you, bro, you take the picture of your room and then you tell me rather, except for making use of AI, can you edit the picture in a way where you might be able to increase the length of the door? No, right? You cannot. Why? Because that image, which we call as the bitmap image or the JPEG image or the PNG image, that specific point of a part of image is basically pixel based, and pixel based is color based, and you cannot change it later on. What the vector images are, the in vector you do not need these different sort of color combination. Your vector images are pretty plain, they are pretty basic because they only include these basic lines. And it's not like you need to create your image based upon different color combination, that you need to color this box blue, this box, the box up here yellow, and then the box up here dark blue, or like whatever in between. We have multiple boxes, right? So we do not want to basically color all of them separately. What we want in this case is that on our screen we don't have any sort of pixels. Yeah, for you to see it, definitely for you to basically see it on your screen, the display coming to you would be pixel, but it's not like that the image is formed based upon the pixel. The image is created using some sort of lines which can be adjusted. So I can basically adjust those lines. I create this, I create this, I maybe create this. But now if I want to change it, I want to change the dimension. Now up here, this circle cannot be changed. If this image has been created, I take it from the camera, I cannot change it. But up here, if I want to change this, I can basically alter this no matter how I want. So I want to make it this way, like this, like this, like this. Now this is basically what we call as the vector images. These are basically images which are not limited to the pixel colors which were created at the first place. These are the one which are flexible, which you can basically change. Now the point here to note is, while even your question is correct, that to be honest, at the end, everything which you can see visually has to be represented through pixels. But the pixels which you are looking up right now is of the monitor. It's like the monitor's pixel. But the image was not created based upon the pixels. But up here, the image was basically created in a way where each pixel contributed a role, because each pixel had a different color. And these vector graphics which we have, they are not colorful like the bitmap images. These are pretty bland. These are pretty straightforward. So like just a shape like this. Now this won't require these colors, right? So that's basically how do we define both for? Okay, now the thing is, this question would not be tested. It's just for your own understanding. This concept which I just explained to you guys, because you guys were asking questions, was something which you all would be required to know in your AS level. So it's not relevant to you guys at this point, but just for your own understanding, this is the main difference between the vector and normal photo. So now if you have the normal photo where you have the bitmap images and all like PNG images, JPEG images, you would be using a photo editing software. But if you have like a vector image where, like right now I was adjusting the line on my own, we have a proper app for this where you can do multiple other functions with it too. So for that, you have a graphics manipulation software. So that was the whole purpose, that you have these graphic manipulation software, which is a type of application software that allows you to manipulate them. Say, apart from that, the last example of an application, but before that, is this clear? Do you guys now understand to some extent what the difference between photos and vectors are? Rayan Hassan, clear? Rayan? Perfect. That's great to know. All right. So now we have one last sort of an example left, and that is apps. Now, this apps which we normally say, bro, app store, or like maybe download some apps. These apps are basically a short form for applications. And while we say this has to be the last example, this apps literally includes anything. These are any sort of softwares which are running on your mobile phone, on your tablets, on your computer. So like anything you download from your app store, from your Google Play Store, from the Microsoft Store, anything you download from the Xbox Store or the PlayStation Store, everything that's being installed on a computer, on a phone, on a tablet, on a console, on your laptop is basically known as an application. And how and why is it an application? Because this is a specific software installed within your computer that allows you to do a specific task. So you might download let's say VLC. Now VLC is a software which allows you to play videos. You can download Google Maps, GPS. You might download now, even though we have a camera app in our phone, we are still downloading maybe like Snapchat. Now you can take images on Snapchat too. So you can like literally have applications for any purpose, for any given purpose. And that is basically, just for your own understanding, this apps is now a short form of all the other possible applications we have in world. You have your finance banking app. Let's say you have the Mizan banking app. That's an application. You have, let's say, Clash of Clans. Clash of Clans is also a game, right? So a game is also a type of application, and so on. Everything which you do on your phone which is there for a specific purpose, whether that's entertainment, whether that's motivation related, whether that's for your own productivity, if it's doing some specific task, it's known as an application software. And here an important point to note is that these application softwares conduct those specific tasks which are relevant to a user. So like for me, I want to get entertained, so I might download Clash of Clans or Clash Royale to play a game. But for instance, if there is something which the computer needs, something specifically related for the computer to work in the right way, for the computer to work, that is not an application software. The program which we need for the purpose of the computer to work in the right way, that is known as a system software. And these were the features we studied last night. So Hassan Abdullah, these were like the general features of system software. What they do is they control and manage the operation of computer hardware. They provide a platform on which other softwares can run. They basically allocate the resources for you to what do we call it, basically run in the right way. Then they also provide this interface where you can see that you have a desktop, or like if I have my operating system, if I have my Mac iPhone in front of me, so right now I can basically scroll here and there. This interface, this thing, I'm not writing any code to open anything, right? So this human computer interface is something provided to me by the system software. And what are like those common examples of system software? Operating system, utility program, and device drivers. So right now we're going to be basically exploring some of the examples related to system softwares, and then we will be looking into utility programs explicitly, because we are aware of what an operating system is and we are aware of what device drivers are, right? We just are not understanding what utility programs are and what they generally do. So now to understand that, I would be similarly, just like before, pasting one other image which summarizes this whole thing in a pretty good way, right? So we have this as a pretty good summary, just to give you a good hint and understanding into what a system software might be talking about. So now what are system softwares? These are those specific type of softwares which allows the hardware to run properly. And while running properly, they also allow the user to communicate with the computer, right? So like now we are talking about that software which basically allows me, the user, to communicate with the hardware, right? So if I want to communicate and make use of the hardware, the computer's software and hardware is basically interconnected using these system software. So this is like the formal introduction into what system softwares are. And now we have multiple sort of examples of what a system software could be. Starting off, we have the one which is most commonly known, that we call as the operating system. Your Mac OS, your Windows, your Android operating system, your iOS, your whatever computer includes like Linux, or maybe we have like so many other operating systems present. These all operating systems are that specific sort of application which are running in the background of your computer. But without this, your computer cannot run. Why? Because it is that software which manages all the basic functions of your computer, right? So without this, your computer will not be even user friendly. So like it's because of this operating system that you can basically click on icons, you can basically open specific folders, you can create new folders, you can copy stuff. Like for instance, operating system allows you functions like input output. It allows you to communicate with the computer. Like without having Windows installed on your computer, can you access the memory somehow? Pretty difficult, right? So basically operating system is the gateway for you to access the computer's hardware. So you access the memory using your operating system. Then it's the same operating system where you might be thinking someday or sometime that what if, like, let's say we discussed the example of RAM in the last topic, right? So we said that, let's say, if your RAM exceeds a specific amount, if it exceeds a specific quantity, it crashes. The computer should crash. But why does your computer get crashed? It's because the computer understands that the RAM can no longer basically deal with it. Now, it's basically because the computer can handle error. This is like an error handling program where it stops you and it crashes that program. Because what if the RAM is like, no, bring in the data, and the RAM explodes? What is preventing the RAM from getting exploded? It's basically these error handling techniques, and these techniques are also implemented by your operating system. And without them, you basically also have other features like maybe loading stuff, maybe installing other stuff, running other games. So like I have my Windows, let's say I have like a Windows computer with me, let's say for instance, and then I want to play Fortnite on it. So like I download Fortnite onto that computer, right? But I have like the Windows. So how it works is that you have your computer's hardware, right? And this, over this hardware, the first direct communication layer is basically known as the operating system, or the OS. This OS directly gets in touch with your hardware part, and it allows you to basically communicate with the hardware the right way. And then above this operating system, we installed other sort of application softwares, and these application softwares are then installed on the operating system. And then the operating system basically allows, because operating system is a system software, it's not an application software. So it's the duty of the operating system then to assign and the resources, and to basically allow this application software to access the hardware, right? So it's basically this model being followed over this whole path. Apart from that, your operating system also deals with, like, let's say, managing of security. So you might have your antivirus being running, you might have some sort of user management stuff related to security, you might have like passwords being set up, the screensaver, but those screensaver will be again discussed under utilities though. But still, like, all that stuff related to security or any other function which explicitly is done by your operating system comes as a system software. And without your operating system, your computer would not run. It's just the same way your Windows gets corrupted, or you buy a new laptop, you're going to know that it's not of any use to you, because you can literally not use it for any set purpose, right? कुछ कर ही नहीं सकोगे उसके ऊपर. Then secondly, the second part you need to understand, or the second system software which you're going to be learning, is basically known as a compiler. Now, what's a compiler? So if you guys are now currently studying programming, right? Not at this point, but not even pseudocode. Pseudocode is not programming. But like later on, if you guys opt for computer science in your A levels, inshallah, you're going to learn a programming language in your A2. Or like if anybody of you wants to study it in university, like the way I'm doing right now. So we study a programming language. But now this programming language works in a way like, let's say if I write a command in Python, it's going to be something like print, and then these quotation marks, hey, and then quotation marks, and this specific line, when it's executed, this line will be basically outputting hey. But now the thing is, your computer does not understand print, hey, and all that stuff. Your computer only understands what? It understands 0 1 1 0 1 0 1 1 0, right? So who is basically the translator sitting in between, which is converting the programming language into machine code? A machine code is basically talking about binary. Machine code and binary are the same thing, right? So who is the intermediate translator sitting in between? So this translator, which converts the programming language into a binary, is known as a compiler. So it basically compiles whatever programming code we wrote and it converts it into binary. And that is also a system software because it allows us to access the hardware, right? The way we write the code, we can basically alter the function of the hardware based upon that. So a compiler is that program which translates a program written in a high level language. What's a high level language? A high level language is any sort of programming language which includes these English related statements. So like the Python, right? See, Python is included print. Print is like an English word, right? Anything which any programming language which is not explicitly directly in what you call binary or maybe in assembly language and includes anything related to English. So like the one which we have, so you can say Java, C++, C sharp, Python. Any of these programming languages are basically high level programming languages. There are these binary or assembly languages. Assembly, we're going to be looking into this inshallah later on too, but these two things are then low level programming languages, low level languages, say LLL bolte hain. So what the compiler does is that it converts these high level programming languages into machine code so that the computer can understand it. And in this, the point here to note is that the code which you write, which a programming computer programmer writes, as in terms of the programming language like Python or something, that's known as a source code, right? So the up down here, if I'm writing this is my source code. But once it's converted into zeros and ones, the zeros and ones is then known as an object code. So you see, the code which is then produced after compilation is called the object code, and the object code is basically the one which your computer can understand, right? And once it's converted into zeros and ones, your computer does not need a compiler again because now you have the zeros and ones present in front of you. So that is one other sort of system software which basically does this whole thing. And you see the examples are mentioned beneath two of high level languages like Python, Java, Visual Basic, Fortran, C++, Algol, and like the other we have nowadays, for instance, the C sharp and all that stuff, right? So that's basically a compiler. Then we basically have one other thing known as a linker. Now, what's a linker? A linker is basically another sort of system software in which what happens is that, for instance, we are working on some software, right? So you're going to note that the softwares which are basically created by these big companies, they are basically including multiple smaller aspects. We're going to discuss this once we get to paper number 2 inshallah. But for now, just know that when we talk about softwares, your softwares can be basically divided into further smaller types. So for instance, I'm creating a game. Okay, so this game can firstly have, let's say someone might be working on its code related to missions. Okay, the other person might be working on code related to leaderboard. Okay, so we basically have two teams working on two separate codes. So this team writes their own code, this team writes their own code. They both compile it separately. So we have 0 1 0 1 1 0 0 using the compiler, right? 1 1 0 1 0 1 0. Now you tell me, when you have a, sir, is the compiler installed separately or is it already come with the OS or not? That's a great question. So your compiler basically comes alongside the programming language which you install on your computer, right? So it's not like present on your computer when you want to. So it's like if you want to do programming, you have to install that programming language on your computer. So like if I want to do C++, I need to install C++ plugins, and then I would be using a C++ authorized or maybe a C++ familiar what do we call it, optimized, perhaps C++ optimized compiler, which I can download from the internet. So we have multiple compilers. You can even download compiler for your own computer. You can look up into PyCharm. So like your PyCharm is that specific compiler or interpreter, which is now Python is not something which could be compiled, by the way, but your PyCharm is an IDE. We're going to study this later on again, but your IDE basically is a set of tools which basically comes alongside a compiler. What about files written in an HLL that needs to be done? Acha, so what happens is that this part, this compilation part, that's done at the programmer's end. The programmer basically converts the whole programming code into zeros and ones. And then basically these zeros and ones are then combined together into folders and set of files which you directly install on your computer. So once you install a file on your computer, it's directly in 010110 manner. But you just basically see the file name and you just click on it and run it, right? So you do not get to know that basically there is some programming at the back, and that programming has been converted into zeros and ones due to the compiler. So right now up here, the same point was mentioned that once a program is compiled, this first program is being compiled at the programmer's end, right? This is done at the programmer's end. Programmer's programmer end. So a programmer basically compiles it, and then the machine code can be used again and again to perform the same task without recompilation. So once it's compiled into zeros and ones, it's being shared in a way where you are not given the source code. You are not given the source code. The object code, the main binary code, is basically then shared with all the users, and they do not need to recompile it again. So this compilation part is only done at the programmer's end, right? Yeah, perfect. समझ आ गई? Clear, right? All right, perfect. So now we basically saw that we can have these two different codes created. And now this programmer, team A, created their own code for missions. The team B created for their own leadership leaderboard. But now if I want to create a game, definitely both of them needs to be in one file, right? It's not like I will be running a different file for playing missions and I want to be opening a different file for checking the leaderboard. They need to be in a single app. So that specific tool which is used to combine two object codes, object code number one, object code number two, the one which combines both of them to create one new file, let's say, like I'm just mentioning this on my own, is basically known as a linker. So it's basically the role of a linker to link two object codes together. So that's one other type of a system software, where a linker is that computer program that takes one or more object files produced by a compiler, and it combines them into a single program so that it could be run on a computer. Say, for example, many programming languages allow programmers to write different piece of codes called modules. So like this specific section where one person is dealing with one specific segment of the main program. So this main program was divided into two modules. Module number one, and this is module number two. We're going to come to this inshallah in paper number two too, so don't worry. And then basically these are then different what do we call it, separately compiled, and then at some point they would be necessary, right? So if I want to create a game, there would be definitely multiple modules and I want to combine all of them. So the software used to put all the modules together to form the final program is known as a linker. That's the whole purpose of a linker. Apart from linker, the fourth operating system software, which is really important for us to understand, is known as a device driver. Now, we already studied device drivers previously too. It's basically that specific software which is used for the purpose of translating your actions on hardware into the binary code for the computer to understand. So you pressing something on keyboard does not denote zeros and ones, right? But you're like writing MAAZ on the keyboard. It's not giving 0100. It's basically some presses. So that press which you do on keyboard, the signal produced by that is in terms of electric signals. And that signal being converted into zeros and ones is basically done by your device driver. So a device driver is that software which enables one or more hardware devices to be communicated with the computer's operating system. Without this, you cannot basically work with the hardware cannot work with the computer, because all the hardware devices connected to a computer have some sort of driver. So like if I have a printer with me, so if I have like my printer, this printer is being connected to my laptop, let's say. But this up here has some electric functions or some other sort of signals. What is basically converting this into zeros and ones which the computer can understand? It's basically my device drivers. These device drivers are the translators sitting in between, which convert the actions of the printer into a form which the computer can understand. And so basically the device driver talks about the same thing, that all hardware devices that are connected to a computer do have a driver. And because if it's not present, then an error message would be produced, because the computer cannot understand, even though you might have seen, like, if I get this graphic tablet but I don't download the driver of it, in some case it might not be even working. You get yourself a new what do we call it, graphic card, maybe some RTX 4080, you get it and you install it in your computer, but you don't install the device drivers, the GPU's driver, you're going to note that it's not going to work. Why? Because for the computer to access the properties of the GPU, there needs to be a translator sitting in between like this. And for that, that translator is what we call as a device driver. Done with this too. And now the final example of a system software which we are going to be studying is basically known as the utility programs. What are utility programs? These are basically those type of system softwares which are basically designed to carry out specific tasks on a computer. Essentially, you might be saying, sir, the same thing was also the definition for the applications which we just studied under application software. But do know, when we talk about utility, utilities are usually related to managing and maintaining the computer's resources, managing and maintaining computer's resource. So if there is a specific software which carries out a specific task, but with the intention of managing, maintaining, and controlling the computer resources, then it's basically known as a utility software. Common examples are like antiviruses, anti-spyware. Gonna come to the difference between them in chapter number 5, so don't worry for now. Then a backup of files, maybe there is some error with your folders, the disk repair, maybe the analysis which allows you to understand how much how much capacity is left in a specific drive. Then file management, the one which allows you to delete data, delete folders, create new folders, compress them into what do we call it, zip files and all that stuff. Then security related stuff, screensaver, disk defragmentation softwares and all that stuff. Now, right now, examiner puts a great emphasis on these. So we're going to discuss each of them separately. It's really important because we should be aware of what each of this utility software do. We're going to look into each of them. Say, but sir, what about stuff like Windows Defender, which is an antivirus but is part of the operating system? Now, your Windows Defender is a utility software. It's part of the operating system, but it's basically the operating system installs a utility software. So that is the same reason why we call it a system software, right? Your system software are those softwares which are basically installed on your computer for your hardware to run properly. So you install your operating system, and alongside these operating system, when you install an operating system, automatically most of the utilities come alongside the operating system. So basically they are not separately installed, because we all are aware that non-computer science kiddos, or perhaps even anyone of us, would never be thinking or wondering why will we be needing something that would be there to control the computer resources. All of this set of stuff is usually, not all of them, maybe mostly, are installed alongside the operating system. So I'm going to write this up here too, installed alongside the OS. So when you install the operating system, you have sort of built in all of these items. So like the way you said, the Windows Defender, which you get alongside the operating system, when you install the operating system, just like before, if we come up to this model, we have the hardware, then we have the operating system. Upon this operating system, we have the application softwares. But then we also have some brothers up here who are helping them, brothers and sisters, who are helping the operating system run in the right way. And that is what we call as the system softwares. So these system softwares are usually brought by the operating system on its own, or if not present, then we need to install them separately. But the way you said, like Windows Defender is part of the operating system, it's basically that set of software which comes alongside the operating system. Is it clear now, Hassan? Perfect. All right, now we have seen these common examples of system softwares. This should give you a good idea into what system softwares are all about. At this point, we basically need to look into what do we call it? क्या नाम है? क्या नाम है? These system softwares in a much not systems or these utility softwares in much more detail. So we basically need to see what are these each of the separate antivirus, anti-spyware, screensavers, and all that stuff. We're going to look into each of them separately, and then we need to understand. Now this is an important point for you all too. You should be aware of all these utility softwares. ये एग्जाम में आ सकते हैं, so do keep it in your mind. Mess up ना कर देना. Same. So do know these utility software. So we're going to be starting off with the first one. Let me write this up here. Utility softwares. Utility softwares. Now, the first utility software which we have in our syllabus at this point is basically none other than antivirus. So antivirus is the one which I feel like a lot of us are already aware of it, right? It's even from the word antivirus. It's basically that specific sort of software which guards your computer against being infected by malware. So the software that guards the software that guards your computer that guards your computer from being infected by malware. Now, what's malware? That should be a question in your mind, right? Malware is basically everything that can hurt your computer. Now, we generally believe it's only virus, but there are multiple other things, even except for virus, which are categorized then under the word malware. And we're going to study malware later on in chapter number 5. More details about this in chapter number 5. We have like a whole topic discussing what malware is, so don't worry. I'm going to discuss all the possible examples, and inshallah, you're going to love malware after that. So don't worry. Abhi ke liye more details in chapter number 5. So your antivirus is that specific utility software which comes alongside the operating system in most cases. Otherwise, you install it on your own, but it basically guards your computer against these viruses. Now, what they do usually is that it has some sort of a bit of common features, and those common features include, like when we talk about common features, we need to highlight what are the commonly done things by your antivirus. So, like it scans all these softwares and files before they are run or loaded on a computer. So, like point number one could be they check and run. They check all files and softwares before they are run on the computer. So like you install or you copy something onto your computer, your before they run on your computer. So basically you copy something on your computer, and you're going to note that if it has a virus in it, your computer directly tells you that, oh man, you cannot install it. And it's not only files, it's also related to your softwares, right? You install something out of nowhere, and the computer automatically deletes that file before you even getting an idea of it. And that's also a reason why maybe a lot of you might not be aware of this, but like when you are cracking some softwares or cracking some games, usually you think like the folder include, like when you download the cracked pirated file, you get a folder alongside it which is known as a crack folder, right? A crack folder. But you open that folder and you see that there is nothing inside it. Why is it? It's basically the moment you copy that folder onto your computer, the moment you extract that file onto your computer, and you get the crack file, the antivirus automatically scans it and it removes it because that specific file is highlighted as a malware. And even though we might get the software pirated for free, it's important to understand that in most cases, that specific virus can be a virus or a malware which can infect your computer. So, for that reason, restrain from using any sort of pirated stuff. It's not, yeah, exactly. It's not you have the steam.api file. Okay, yeah, exactly. Then I used to access one specific AutoCAD and these sort of related stuff. I guess there was this computers, not computer, basically architecture related software known as etabs. And in that there used to be main file like isperc के नाम से, and then the computer automatically used to flag it that it's basically something like that. So okay, that's great to know. We do have multiple such websites, though, a lot of them. but still, like, to be on the safe side, you should prevent them. Say, so one feature of antivirus is to basically check everything before you even get an idea, and to basically either flag them, or if it's something really really of that nature, then it automatically deletes it. But for that reason, they carry out heuristic checking, where, like, you might be wondering, how will the computer get to know whether this is a virus or not, right? So a lot of the times, even though now this should be a question in your mind, sir, the crack file which we have now in our computers at this point, this is not like a virus. Like, maybe it might seem like it's a virus, but it's not a virus, because it's like a crack file which might help us bypass some restrictions. Now, how does the virus believe that it's a virus? Sorry, not a virus. How does the antivirus basically come to the conclusion that it's a virus? For that, what the antivirus do is that the antivirus carries out a specific process known as heuristic checking. So they carry out heuristic checking. Now, what's heuristic checking? This word is important because examiner can directly ask you about it. So heuristic checking basically involves one extra layer of thinking. What it does is that this is that type of checking in which the antivirus basically looks onto the behavior of the app, and based upon the behavior of the app, it indicates whether it's a possible virus or not. And then this behavior, which it denotes from each of this application, it's basically stored in a database. So if it's like, okay, if there is a software which is trying to access this part of the memory immediately, this might be a characteristic which was done by XYZ virus in the back. So because the antivirus database had this information, the moment a file came up which might not even be like what do we call it, a virus, but it was trying to access the memory immediately, the antivirus will be like, okay, this is showing and portraying the behavior of a similar action which was done by a virus, right? So this might also be a virus. So it's like, okay, let me close it. Let me not allow it onto the computer. So this is what we call as a heuristic checking. So now to write it up here, I'm going to say that this is the type of checking. This is the type of checking in which the behavior checking in which the behavior of the file indicates, in which the behavior of the file behavior of the file indicates whether it's a virus or not, whether it's a virus or not. So based upon the behavior which it basically denotes, we get to know whether it's a virus or not. And the behavior of the how does the computer now get to know whether the behavior is similar to some other virus or not? It's basically the antivirus comes up with a whole database which involves all the behaviors of the previous past viruses. So if there is any new virus found out, or like if it flags something and you're like, yes, this is a virus, remove it, it automatically updates its database and adds this new virus onto the list too. So it ensures that your computer is further secured. So the behavior of other viruses is stored in a database. The behavior of other viruses is stored in a database. Is stored on a database. On a database. Then you might be wondering, sir, but like the example which you just gave us, in that it does not remove it. It basically flags it for us. It's not like removing it directly. It tells us that we have detected this, we have quarantined this for this point time being, but it's now up to you whether you want to allow it or not. If you want to allow it, we won't delete it. If you want to remove it, we're going to delete it. So what's that? So that is one other feature of your antivirus, in which what it does is that if any file is detected, it firstly brings it into the quarantine state. See, so if any file is detected, it brings it into a quarantine stage. And then during the quarantine stage, you have now the option to basically alter, what do we call it, whether you want to keep it with you or not. So like if there is something being brought up into quarantine, you can either delete it, or you can let the user make a decision. say. So if the user wants to create a decision, you can basically, it's going to automatically, if the user wants to delete it, it's going to be removed. But if the user says that this is not a virus, this is not a virus, or it's basically a right program, then this program is basically allowed to stay on the computer. But this is a false positive point, which is a big drawback of an antivirus, because it sort of highlighted something which is not a virus, but it categorized it as a virus. Say, so if something is not a virus but has been categorized as a virus, that specific stage is basically known as false positive. So इसका भी आपको पता होना चाहिए. False positive is when the antivirus detects something to be something to be a virus, but it's not to be a virus, but the user confirms that it's not. But the user confirms that it's not. Confirms that it's not. And that's one big drawback of an antivirus, because of this reason, your antivirus in most cases might not work the right way too. Because if there is a virus, to us, maybe it might be looking as a legit crack file, right? So we might allow it. And so for the antivirus, it might be like, okay, this does not include a virus. But what if it had a virus? And just like that, there is a possibility where a file might not be a virus, but the antivirus automatically flags it as a virus file. And then you need to basically allow it, otherwise it's going to get deleted. So that's like one other drawback of virus, which you all are required to be aware of. उसके बाद just keep this in your mind that the antivirus basically carries out full system checks, like once a week or twice a week, to ensure that if there is any sort of virus that is lying dormant within the computer in like those hidden folders, if you do those quick scans, it's not going to be highlighted. But if you do those detailed sort of scans, full system scans, in the full system scans, they're gonna get to every file in your computer, and so they can basically find underlying dormant viruses in the system, underlying dormant malware, and then basically remove that. So it's really recommended that you also conduct like a full system scan at least once a week, to ensure that if there is any sort of such operation being conducted on your computer, you can basically prevent it from happening. And this basically marks the end of the first utility software among the 8 which we're going to be studying, inshallah. So tomorrow we're going to look into the other utility softwares. I hope so we can basically cover them up, hopefully, inshallah. So that is all for today. We looked into utility software, understood what system softwares are, and then discussed a few examples of the application softwares too. And that is everything for today. Now, are there any questions, or are we good to go? Perfect. Zakia, any questions? That's perfect. That's great to know. All right, guys, that's everything for today. Then we're gonna end the class because it's 10:03. See you guys, inshallah, tomorrow at 9 p.m. sharp. Try to be on time so that we can start off early and not at like times like today we had to like literally wait 10 minutes. So see you guys, inshallah, tomorrow. Take care. Allah Hafiz. Allah Hafiz. Allah Hafiz. Thank you.